Turn that gain level up. I'm getting criticized. Man, BB, 1 minute you're exposed and it's perfect, and then the next minute you're overexposed. So watch. Not overexposed, not overexposed, overexposed. But now all of a sudden I take my white fleshy bit out of the screen and it's all perfect resolution and nobody's got to tweak any settings on their screen. But then I translate over here to the workbench. Oh, it's so bright! Let's see, do I have an auto button? I do. Push. Full auto. Now, according to Sony, this is all the right exposures. To me, that's overly bright. But we're going to do this in fully autoed, right? Let's see. Auto, auto, push auto, push auto, push auto. And that amp is not that dirty. It is literally not that dirty. Gentlemen, this is the Metron T500m. This is, like I was just saying on the phone with some guys I was just on the phone with. I said, man, I got to go work on this very rare amplifier. And I said, what do you mean by rare? I said, well, it's like, how does Chuck Norris eat his meat? That's right. He only eats unicorn steak because it's so rare to find. This is that. This one's been here before. This is the one that showed up here from my friend Zane at Big Rig Radio. It went off to go be in this guy's mobile, and he set it up and he built a beautiful install around it. And he says that he's having I have a note. Now remember, we're on full exposure auto. I don't know. We're gonna run with it. Okay. He says, when I key it, it will only output 200 watts if I repeatedly key it with the foot switch and it comes back to full output. This happens more frequently when you are keying the amp more frequently. Not for an extended period of time, just keying it. I told him, I said, well, bud, I'm sorry you're having that problem. Like I said, all I did was basically make sure it works, and it was just not 1,000%. So I said, send it back. I sent it back here, and that was in September a year or so ago. Not last year, but the year before that. And it got buried in the 800 pieces of equipment that got sent in here the September before last, which I am still desperately trying to struggle to get through. Yeah, another day we'll cover all that stuff. Needless to say, he called me the other day and says, hey, have you had a chance to look at my amp yet? And I went, oh shit, no. So, nah, come on, there's no way that that's the right exposure level. There we go. Listen, you guys, I've got a lot of different hats that I wear. I shoot I wear the hat of telephone operator, parts orderer. I'm not over the shipping. My beautiful, wonderful wife takes care of a lot of that for me. The inventory, the books, and then on top of that, I got to be the personality, aka the talent. I actually have to do the work instead of just talking about it. And oh yes, then I have to be a cinematographer, and then I have to be a welder, and then I have to be, on top of that, a video editor, and then I have to be a publishing expert, and then I have to be a social media consultant, and a lot of different hats that you wear over here to do this one little job. And it's okay. I'm not bitching. I'm just saying, hey, if for some reason I accidentally leave the gain a little high and I put up a YouTube video and I'm talking about a vacuum capacitor, don't get upset with me in the comments. It hurts my one emotional feeling I have. Now, if I had feelings, I would be totally sad. But being an amplifier repair shop / amp builder, you very quickly learn that you have to become a emotionally devoid monster to be able to handle a lot of the stuff that goes on. And my friend out there that is making the comments to me, he's just literally, he was trying to point it out to me saying, hey, do you know that there's an issue? And what happens is I've got this really high-end camera, which is way more camera than what I needed. I ended up buying like a camera that you would use to shoot a full-up cinematic movie on, and what I should have bought was like a different version of camera. Its automatic settings are not the greatest in the world, so I found it's easier to do manual. But when I switch contrast, like, let's say we're going to go look at this. Well, as I'm zooming in, I'm having to hit another button, and I'm running the gain up. And then when I decide I'm going to translate up here to the watt meter, I have to manually run the gain down by my finger. And every once in a while, I skip a step, and then my fleshy soft pink bit comes out here on camera, and it looks like this. So I just want to come out and publicly say I'm sorry. I'm sorry. Please forgive me. Bear with me. We're going to make it better here. Towards the end of this new year, we're going to get a completely different camera yet again. Lots of good stuff out there to look at. But today we're here to talk about this Metron. Now, I don't know what's going on with the amp gauge up here in the front. Let me show you what's going on here. Okay. Hopefully that's salvageable. Hopefully, because I've seen these listed. I just don't want to go and deal with it. I'd rather just fix what we got. So, before we go any further, yes, we got coax hooked up. Yes, there's power wires hanging off the back. No, not hooked to anything. So let me take just a minute. And let's take the lid off of this thing and let's see what's going on underneath the hood. I am going to put the previous video for this unit in the comments or in the description. Okay. I was afraid of this. Grab something to prop this up on. I don't remember these being burnt. That is your input attenuation pad. Okay, so your RF comes in and it goes through this attenuator, and then it comes out. It goes through this 4-port splitter, this old Wilkins style splitter. This has been getting the brake speed off of it. I don't remember it looking like this. Sorry. I don't remember those looking like this, but so if we look, you'll see that this attenuator here has gotten so hot that it's actually unsoldered itself. This is all one big giant crack around that solder pad. Let's see what else we got going on here. God, this meter shunt looks like it's been on fire. I mean, that was nickel coated at some point, and now it looks like it's been melted. This is such a rare piece of equipment. This shares some components with the Henry SS750. Anyhow, this is your bias control circuit down here. This is your trimmer pot for your bias. This is the thing that drives this transistor. It's the voltage regulator for it. This band board that's here on the back is the same one that's in the Henry SS750, The output plugs also share a lot of the same characteristics. You know, this is going to be like 80, and then up here is going to be like 10. See, once again, I moved the camera and now the gain changed a little bit. Let's just do push auto, push auto. That looks okay. I'm going to leave it there. That's discouraging to me. That is very discouraging to me. These caps are all buggered off, so we'll replace these. They're going to be much smaller though. But, I mean, these have gotten so hot they're now dry. This case is split, that case is split, but they're dry. You can see the shmoo is leaked out of this one here and leaked out of this one here, and there's shmoo around the edge of this one here. So, in theory, it's working. We're putting too much drive into it. The amp is getting too hot, and yeah, I want to look at the, very interested in seeing if we can get this salvaged. This is literally one of these deals where I don't mind if you watch. But y'all keep your mouth shut for a minute. Okay. It's just as bad. Damn it. Let's put that down in there like a swizzle stick and we're going to move it around a little minute. So make sure we get glue all the way down to the very bottom of this hole. Don't you drip on me. There we go. Now, as we all know, Sinelic glue has a really bad tendency to like migrate all over the place, right? So we don't want to use very much. That's why we're doing like the dab process here. Pot smoker buddies out there know what the hell I'm talking about. Okay. That might save us. We'll see. Okay, so the idea with the Senelic is that we got to reinforce this obviously made in the 80s plastic. I can't show you now. Do I got any glue on my fingers at all? No, I can't show you now, but the other side of this meter, this side on the opposite side, it looks like this, is all spidered and broken from age, and it's strictly from age. So it's the reason I went ahead and I took that second screw out, because who's to say that this thing even makes it home in shipping and that other screw not pop out, right? Well, we're going to let this sit. We're not going to pour any quick set on this or anything. We're going to let this sit and naturally set up nice and slow, even though it doesn't affect how hard the glue gets. What I'm worried about is the vapors. As this stuff outgasses, if it's not in a very well ventilated area, you and I both know it's going to fog the crap out of that plastic. We're trying to avoid that. So I'm going to set this thing over here. We'll come back to this maybe tomorrow. We'll seal that lid back up. Maybe tonight. But I found with Senelic that if you do get a little bit on your finger and you do touch that clear lens plastic, don't freak out. Stay calm. Chive on. They make this stuff uncure. It's cheap. It's like $4. Put some of that on a Q-tip. Very carefully start working it. And eventually it'll uncure the super glue. Now, how's it going to affect the plastic? Don't know. We want to avoid that as much as possible, right? Which I think we got out of this deal without touching or screwing up the lens. Okay, let's look at this Metron again. Metering circuits are the coolest thing in the world. I mean, they really are. They're nothing short of magic. Especially the amp circuit. How this particular meter circuit works is it attaches on the positive side of the breaker. And then the other side of it attaches over here. On the same wire. The differentiation between here and here in the electrical potential that's coming through this line generates enough current to drive that rudimentally accurate meter forward. It's kind of neat. Meter shunting, that whole thing. God, learning about that years and years and years ago. I'm like, seriously? Yeah, seriously. That's how they work. Yeah, seriously? Yeah, seriously, that's how they work. They're nothing short of magic. I don't care. We're talking about measuring something that we can't see, can't smell, can't taste, but we can definitely feel it if the voltages are right. We're talking 3 pieces of wire. Wire to here, and 2 wires back to the meter movement. That's all that's required to make that circuit work. It's friggin' sick. And I don't understand why people in the amp building community can't put amp meters and stuff. I don't get it. Especially tube amplifiers. Or put a frickin' grid meter. It's no harder. Put the grid meter in the tube amplifier. It's necessary, you guys. Okay, back on topic. I went back and I looked at the other YouTube video, and I was thinking, oh, well, here it's pretty obvious. He overdrove the holy bejesus snot monkey out of it, and that's why it's not working right. Well, no. This shunt was the same way, and what this is once again, we're going to take an inducted coiled piece of wire that we know its actual resistance and all that stuff, and we're going to go to the other side of this, and when it sees a certain amount of microvolt that is generated by the differentiation in current, it'll trip this breaker. Okay. That looked the same in the original sales video. These resistors looked not this bad, but they were there, and they were slightly discolored in the other video. I see some stuff in here that is cold soldered, like this input transformer is a little bit cold soldered, but I'm not going to get too excited about any of that. See over here in the top corner of this box over here, this guy right here is a thermal switch. And if it gets too hot, it cuts out. This white and this blue wire cut out, and it takes our keying circuit out of line and says, thou shalt not run no more till I cool off. and it's directly attached to the heatsink. So it's got an idiot-proof switch in it. So the only other thing it could be was something breaking down underneath temperature, or we've got ourselves a dirty relay. This is a pretty common relay, not anymore, but it was in the 80s and very early 90s. They're in a lot of Henry equipment. Pretty common relay. It would not surprise me any at all that we have a breakdown between here and here. There's not a lot in this circuit. RF come in, click, goes through connections, goes out through a trace, which I've yet to identify because I haven't looked that close at it, and then it pops up here, goes through these attenuators, which are very slight. I mean, hell, there's even an inductor that's in there. And then it comes out and runs to the splitter circuit. Very rudimentary at best. At worst, because this is, oh, it's not one pan. At worst, I'm sorry, I'm excited because I might have to take the face off, but I might not have to pull the whole board up. But at worst, I might have to pull the whole board up if I can't physically see the traces on this side of the relay, the top side, to see where we have a breakdown. But before I put power to this or even tried to run it, I wanted to look at that meter and see if I could determine what its problem was, because I knew that wasn't a replaceable device, at least not in a timely manner over here. So we got that squared away. These filtering caps, that doesn't mean a lot to me, even though they weren't broke or split or dried out like this one it left here. It doesn't really matter. It's not going to cause the problems that he's talking about. But now what I have seen is in the SS750, in my very limited experience with those amplifiers, which is 4 or 5 of them I worked on, 5 of them I worked on, this band board is a cruxus of a lot of problems, especially the contacts at the relays. I have seen those effed off more times than you care to imagine. So I can't remember if the bands stay latched when you turn the band selector knob to where it needs to be, or if they latch with this relay. I don't remember. So we're gonna have to put power on this thing, and we'll get her done. I also want to point out the nice thing about these guys is they really thought some shit through. You see this? It's a plug pin out. It says this is what this is, and this is how this works, and here's the pins. And everyone's got a number. Pin 1, pin 2, pin 3. Them smart. They be thinking. Even more than the engine is a Henry. There's a remote for the Henry. It's not even labeled. So, I'll walk you through the process here. I got the ICOM 7300 set up. We're at 14.150 megahertz on AM. Let's go over here and let's take a look at what we got going on. It's a 2 through 30 megahertz 50 watt element and a 100 watt element 2 through 30 megahertz. The data that we're going to get off this 5 watt slug is pointless at this frequency, but I just picked the middle of one of the ham bands to play with it. So let's come on down here, and I had another one of these that come through here, and what ended up being the deal was there was a wire broke off back here and it was doing the same damn thing. That wire is obviously still good to go. We've got this in the off position, we've got this in the reset position, which is on. It's actually amp off, amp on. Now the cool thing is he sent me back everything. He sent me back the remote and he sent me back the foot pedal. Okay, so I have his entire setup here. Okay, me thinking, we'd be here. The frequency that we're looking for here is position 8, 15 megahertz, right? Well, let's watch what happens here. So here's radio power. So we're transmitting with about 15 watts of power. We're looking at the average meter here. Remember, 50 watt scale, so all the way to the right is 50 watts. We're looking at that metal meter movement here. So about 15 watts of power. And over here we're showing just a little bit more. Hello, typical ICOM. On AM, will swing forward just a pubic hair, but then falls back on its face on the average number. Showing about 14 watts there, so we're pretty close. Now, let's step on the pedal. Oh, what happened? What happened? Pedal, key the mic. Pedal, key the mic. Key the mic multiple times. Not happy. So, let's make ourselves an adjustment. Now happy. Radio drive, amplifier power. Okay. Let's change frequencies now. Let's go on down in power. So, off or to remote. So position 1 is off. Position 2 is 3 megahertz. So let's do 80 meters. AM, once again. Okay. Remember, we're working with a completely sealed, bonded, and grounded system. Completely sealed and bonded system over here. So we're talking into a dummy load. Complete. And I mean with no cheap girly coax either. Once again, same amount of power level. Hello. 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 Great input reflag. Hello. Remember, I got the voltage all the way down, and I'm not looking for big numbers. Okay, so 80 meters checks out fine. So let's go ahead and jump on up here to 14. Oh, wrong side in. Beep. Can't do that. Here we go. Okay, same amount of power. On foot pedal, off foot pedal. On foot pedal, off foot pedal. Wow, okay. 80 meters dead there. Dead there, dead there, and then we should go all the way here and it should be bypass. Yep. Okay. Not happy. So let's go here. Still not happy. 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 All the way over to 30 megahertz bypass. Happy. Hello. Hello. Okay. Sorry, I'm working through this with you guys live, and I'm plotting the band in my head. So why does 14 work better there than instead of here? Radio, amp. Okay. There it is. What was that all about? I think we might have just found our problem. Okay. Dirty relay. Okay. It was not working right in my mind at all. So let's see if I can get this in frame. Now what I'm going to tap on is the top of this. Just going to tap on the electrical armature of the thing. Look, now I tap on it, it's going to work here. Oh, there it is. Ready, ready, ready. Okay. Cold solder joint or dirty relay contact. Man, I want to pray that it's a dirty contact. The reason I say that is because to take this apart is going to be a buggerty boo, but I'm totally willing to do it so we can experience success. A lot of different things going on here. So, not the relay, pulled it out and cleaned it, and we're getting good conductivity through the relay. But something is going on with the biasing circuit. So let's see if we can get this to work. What you're going to pay attention to is this meter, which is now 1000. We'll look over here. It's 100 watt and 5x, by the way. And you want to pay attention to that amp meter down there. I'm unkeyed. I'm off the pedal. It's creating its own signal. So what we've got going on here is a 10-to-1 reduction probe, and we have this attached to the input bias circuit. And how the bias works, not input bias, just the bias circuit, period. How the bias on this thing works is it's run through these two regulators here, a tip 33 and a tip 22AB. Anyhow, it's created, isolated. This is your trimmer pot, and I've got it turned all the way down because it's a little hot. And it runs through this ferrite bead, down through a trace, through this ferrite bead, across the input transformer, down through another ferrite bead, across this input transformer, through another ferrite bead to isolate each one of these from each other. And then I've just got the probe stuck in here. Okay, so now I got the probe grounded on the case. Let's go look at the oscilloscope here. Look at this haphazard madness going on here. Okay, I've unkeyed. Unkeyed. It is creating its own signal. As soon as I step on the pedal, it snubs it out though. So this is working on a switched bias circuit. See that's probed? That's on the input. So once again, let's key it. Let's watch what it's doing. On the foot pedal, key the mic, off the key, still making power, off the foot pedal, still making power, and consuming power. So it's consuming amps and still making power. So it's technically it's oscillating. Normally when I see an oscillation like this, it is, well, a cap that's broke down. And it won't shut down until you pull the current away, because the circuit's just running away and it's making its own power. Input's feeding to the input, output's feeding to the output, and it's running in a circle. Our flybacks are getting smoking hot. What leads me to the conclusion it's not that, if you can call it a conclusion, is this test here. Off the pedal, on the pedal, here comes our bias. In operation, off the key. Now we come up to our normal cruising bias voltage. That's the reason I have it dialed all the way back. And then back on the key again. On the key, and now it's isolated itself and shut down again. You can't key it for very long like this, or otherwise it's just going to constantly just feed into itself and then nuke down and burn everything up. So let's pull all the probes out of it. Same thing. Off the foot pedal, unkeyed. We're still pulling 20 amps worth of current and we're making all that noise. So we know that it's not the test probes that are causing the resonant oscillation or oscillation period. It's the bias voltage, which has got my eye up. The bias voltage is switched through the transmit-receive relay, which I know is coming out of operation mode. It's lifting. I can physically see it. You know, with the original Mark I eyeball, you know. But the voltage is staying present. I think we need to change our regulator because we're getting good filtered power coming in. I'm not trusting this regulator. And I know if I pull it and test it, it's going to still test good because we're getting valid bias operation. And then every once in a while, I'll key it and I can tap on it just right, and the thing just takes off and makes monster power. Like monster good power. It's definitely not here. It's all in the front end of this thing. So I'm still looking for the smoking gun. God, I'm just having a hard time buying it. It's like there's 3 different problems going on here all at once. Like, we've got a cap breaking down, there's something wrong with the bias, and there's something wrong with the relay, is what I'm thinking in my head. So, let's go over here and take a look at this. It's the closest I've ever been able to get to anything with it not fuzzying out on me. This joint here looks suspect, that joint looks suspect, and these couple of these pass-throughs, like this one up here, looks suspect to me. So I'm gonna go and I'm gonna have me some dinner, but I want to bring you in on where I was at. They have little tiny itty bitty brass journals that are holding this board up. I'm gonna reflow, I'll rework all of this and clean it all up. They've got little tiny brass knobs, little pieces of brass shaft that are being held in place by, well, up here in the front, by some sticky unknown substance. It is all over everything. It was all over the front end of this amp, all over the inside of it. I don't know what got spilled on this thing since it was here. I don't know. Is that the reason this thing's not working? No. I'm just saying it's something got spilled on this at some point and nobody wants to claim responsibility for it, me included. So, needless to say, we'll clean all that up, and then we'll take these little tubes and we'll actually solder them up here on the board. As you can see, this one here is kind of, oh, it's so horribly overexposed. Stop, BBI, stop. Just chill out. I'm coming. This one's actually kind of held in place with thermal compound. That one's just chilling. I'm going to actually solder these on the board, so if I have to take this off again, I don't have to worry about losing them. But this is definitely an amplification issue, without a doubt. This isn't in the relay circuit, is what I'm getting at. And then, you know, I mean, there's just a bunch of little stuff that I'm going to redo in here, like this shunt that's not, I can't let that leave here. My brain will melt down. So, I don't know, we might end up replacing these voltage regulators over here. The driver and the actual regulator. Might end up replacing those, but there's nothing in the circuit that's screaming at me that says, I'm broken. Hey, I'm hard broken. So it wouldn't surprise me if the problem ends up being here. But we're going to eliminate all the things that we can. And what I mean by, sorry, horrible camera work, BB. I apologize to all the YouTube viewers trying to follow along. It wouldn't surprise me if I end up having to replace these two. I'm going to order them anyhow. But we're going to eliminate all the other stuff. Like, we're going to go through and we're going to, if I've got the right valued resistors, I'm going to replace the input attenuators. And I'll spend a little bit more time with the biasing circuit. I want to see how that's actually switched. Because I have seen this in the past in other situations where this relay was just slightly hanging up and it was allowing just a little bit of weep current. Just a pubal hair of pissed off, screaming mad pigs. I mean, pixies. To leak through the connection on one of the, it's not making full cut down contact on it. Then that means you'd lose receive because it all goes, I don't know. The voltage staying on for the bias, I can't have that. It's got to shut itself off and completely neutralize the circuit every time I come off the pedal. We might yet end up buying one of these relays. We might. I should probably buy a couple of them. So I'm going to go on the search for those and I'm going to get some voltage regulators coming. I want it to be a broken solder joint to where I can go, see, look, this one joint's cracked. That's the reason this whole box doesn't work. And it's not screaming at me yet. I haven't found the way to interpret the tea leaves quite yet, or speak its language yet. Okay, so here we are on the bottom side of things. The spacers are all soldered in place. Went ahead and reworked all the solder joints, even though I'm pretty sure the problem's not there. Cleaned all the old thermal jizz off all the transistors. Put new thermal jizz down on the heatsink. Let's go ahead and let's put it all back together. And let's see what happens. Giga-D. Okay, let's start here. So we got it all back together. And I pulled and I checked every single one of these capacitors. And I checked each one of these capacitors. And we're all within tolerance. I want to come back, I'm going to replace these electrolytics. But what I did is I came over and I replaced the input attenuators. Now hold on, don't get motion sick. Here we go. Here's the old input attenuators. These are 200 ohm resistors, and they're like 3 to 5 watt. So 200 ohm, 200 ohm, 200 ohm. So we take 200 divided by 4, we get 50. So it's 50 ohms worth of resistance. And to keep the math simple, we'll say they're 5 watts. So 5, 10, 15, 20. It's a 20 watts worth of attenuation on that way on the attenuator. So once again, 200 ohm, 5, 10, so 200, 400, 600 ohms worth of resistance. And then this one actually was on the same bank, but it was tied back to ground. Once again, it's about a 75 ohm dissipation, same amount of resistance, 5, 10, 15, 20. When you measure these with a voltmeter, the resistance on them, like that one's still 200 ohms. That one's about, I don't know, 125, let's say. This one's about 130, and that one's 200 ohms. The same thing is going on here. That one's all chooched out. That one's way low, but this one's still good. So instead of nitpicking around it, I came in here and replaced those with 200 ohm, 200 ohm, 200 ohm, 200 ohm. A 50 ohm attenuator, but instead of being at 5, 10, 15, 20, now it's at 40 watts worth of attenuation. The same amount of resistance, just a little bit more dissipation. The resistor that goes to ground is this one here, and it's also hooked up to ground. So on this side of the attenuator bank, you know what, let me flip this up on its side and let me show you how this circuit works. Okay, so our RF pathway comes through this choke and gets fed into this pad. I need a pointing device. It gets fed into this pad that runs this direction. Okay, so we've got our resistor that goes back to ground, this original one here, okay? Bank back to ground over here. So our input RF comes from here, goes into this pad, passes through this attenuator. Now, this circuit, this pad and this pad are tied together. This is our input splitter. Now on that same pad, we have another inductor coil with a resistor inside of it. So we have a coil with a resistor inside of it. And then once again, we have another dink, 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 dink. Another attenuator that all goes back to ground. This is a 50 ohm attenuator. This is at 5, 10, 15, 20. So 40 watts worth of dissipation. We're really trying to pull the current out, or the watts out of this thing. Slightly higher watt value, but the same amount of resistance. So we're not attenuating any more signal, we're just allowing the resistors to stay cooler. Now, did that fix our problem? No, that did not fix our problem. But you and I both know, I mean, I went back and I looked at the YouTube video, these resistors are a little bit discolored, but not like this. And I'm not saying the amp was overdriven, because it was not. It's just they were getting rode hard, and especially with this thing locking the way it was and going into oscillation, these flyback resistors were getting hotter than a frickin' firecracker, and these things were trying to do their job and pull the signal off and take it to ground, and that's what caused them to get hot. It has nothing to do with abuse or misuse of the amplifier. Just saying, we built a different attenuator pack on the front end of this thing so that when it goes back to the guy, he's going to have a lot more reliable operation. Now, took a ton of bias out of it, which is this knob here, which controls this knob here, or controls this transistor here, but it's driven by this transistor here. Okay, so this guarantees that whatever we put into it, we're going to get out. And then from there, we use this transistor as a control check, and we use this thing's reference to ground to control this transistor, and this is our load cell. It's the exact same circuit that we use in all of our amplifiers that we build over here, except there's no regulator. This regulator circuit's removed and we use just a diode. Well, that same diode is here in the circuit. This diode's got the appropriate amount of leakage to it. It's good. I went ahead and I ordered this transistor and this transistor. I'm positive this transistor is good. This one is the one that I have in question in my mind. Now, all that being said, I think there's two things that are going on with this box. Absolutely confident there's two things that are going on with this box. One, this relay has just seen better days. It's okay. We've got a new one of these coming. The only place, oddly enough, that I can find that relay currently listed at this time that they have it in stock is on eBay, and it's $100 just for this relay. Ordered it. Now, if I sit here and I swizzle stick this relay enough, you shouldn't have to swizzle stick anything. You shouldn't have to stick your tyrannical dinosaur arms up in here and beat on anything to get anything to work. If you get this relay to latch just right, this amp runs just perfectly fine. For the most part. Then this transistor gets hot from everything else getting warm, and it starts producing all kinds of weird voltages. And then, no matter what you do with this relay, short of double clicking it, because remember, all of our voltage for our bias passes through this relay. Alright? When that transistor gets warm, this thing starts to oscillate because the bias voltage starts to go haywire. So, if we replace this transistor and put a new relay in here that's got smooth contact operation, I think we got it. It's going to take a couple days for this to show, take a couple days for that to show. So, I'm going to put this video footage of me taking the whole front end of this amplifier off. I'm going to put it in the archives. Got the parts coming, so I'll come back to this in a couple days when the parts get here. But I have seen and sat and watched this thing run, and I'm literally sitting there with cold spray going and spraying this transistor, which I know all the joints around it because I've visually inspected, and I also reflowed the joints. So internally there's something wrong with this regulator transistor. Spray it with cold spray, amp works fine, as long as the relay doesn't screw up. The relay is hanging up, as in it'll latch, unlatch, latch, unlatch, latch, unlatch. And then one of the legs on the relay will latch, and then one leg will unlatch, and the other side stays latched. And then you just barely breathe on it, it goes click, and then it disconnects. The metal that makes up the arm on the contact pad I think is bad. I think it's been hot and it's been bad. Just replace the relay, save ourselves a bunch of heartache. I think between this staying latched on and letting the bias leak on, this regulator has ended up getting over hot and has had a problem. Well, the attenuator is trying to pull the signal that is oscillating from the input to the output out, and it's trying to dissipate that to ground. I'm pretty sure that's what caused this problem. So I had these parts. They do if and or the better same job. They fit in the same place. We've got them in. I'm going to replace the caps, and I'm going to set this thing on the shelf, and I'll come back to it in a couple days. But I can literally spray this with cold spray. The biasing issue goes away, and then I flick the special jelly bean on the relay, and the amp shuts down. So 100% of the problem is between here and here. I was hoping it was just a cold solder joint. It really was, but I'm already all the way up in her. Might as well continue and stay on it. I wish I had one of these things. I really do. It's a neat little box. Really neat little box. Really neat little box. Anywho, that's where we're at. Moving on. I mean, you don't get to have the argument with me about how the supply chain is a wreck right now. You just don't. Because this right here has been 3 weeks on the repair list. So the last little segment that you guys watched was filmed 3 weeks ago. This is that beautiful all band, very rare. Wish I had one of these myself, but then I wouldn't even know. I wouldn't. What? I keep that in a closet for someday? Nah. This is that Metron that I've been playing with. So it took weeks and weeks and weeks to get this. Remember how we proved that this 1 voltage regulator was having a bad hair day? Well, that one part was super expensive because people aren't stupid and they're capitalizing on the fact that there's not a lot of spare parts in the United States right now. So here's our new replacement. And the other thing that people are not stupid about is this what I would consider to be very common household relay. I mean, it's in every Henry, every Ameritron. This is made by Guardian Electric. This relay I paid because it was new, old stock, not used, new, old stock, and at the time it's the only one I could find. Now I'm sure by the time you watch this video you'll be able to find one cheaper because of the supply chain issues, but that relay right there was $130 alone because it was new. So as we were experimenting with this in the last little segment of Vigeo, I very clearly remember that if I tapped on the relay just right, everything would come back and start working normal as. Well, I found with these particular guys, you can clean them maybe once, and then after that they just they get a little flaky. So to me, there's too much money in this box. The customer's got too much money. I got too much time and money wrapped up. Might as well just get a brand new freaking relay. $100 key and relay installed, just like that. Give me a minute. We're going to change out this voltage IC. Yeah, same part. Okay, let me change out this IC and we'll be right back. So here we are on 20 meters. It's a 1000 watt slug there, 1000 watt in average, 5 watt slug in reverse. We're cruising at 15.1 volts. This is our bias. That's 0 signal bias. Hello, 1 2 1 2 1 2 1 2 1 2. About 450 watts out of this thing. Hello, 1 2 1 2 1 2. Volt amp meter is working. Hello, 1 2 1 2 audio 1 2. This is the main thing though. This here. Clean off, clean on, clean off, clean on, clean off. What I mean by clean is there's no serious leak down voltage, and as I'm sitting here, I'm running this thing isn't running away and getting stupid hot like it was before. This is dumping mad current, that voltage regulator. So, well, it's causing it to dump mad current. The attenuators are all rebuilt. Hello, 1 2. Hello, 1 2. Hello, 1, 2. Hello, 1, 2. And I'm running an ICOM 7300 into it, so we're making about 90 watts. Probably push it a little bit harder, but ICOM won't let me do it. Hello, 1, 2, 1, 2. Audio. No, that. Hello, 1, 2. It would have hung up. This thing's fixed. I'm going to call this thing a win. I am going to button this up and this gets to go back home. I am so glad to have this thing out of here. I've had it here for like 1.5 years, along with a lot of other things that I'm slowly trying to work towards you guys. Remember, there's a lot of different mouths to feed on different media platforms here for different projects. And everybody seems like they stand around sometimes with their hands out, and I'm doing the best I can to get to everybody. If you don't want me to have your stuff here anymore, please contact me. I will gladly return it to you, because I don't want to have it. Okay, I'd rather repair it and send it home, but if you don't want it to be sitting here waiting for me to very slowly work my way to it, that's fine. Contact me. I'm not gonna get sad. I won't get mad. I won't get glad. I won't get angry. I won't get hangry. I'm starting to sound like a Dr. Seuss freaking thing. Anywho, listen, this thing is fixed. We did new attenuators on it, new voltage regulator for the bias, and this. Expensive, but fixed. I could be able to just sit here and key it before and it would just stay hung up. It'd just keep pulling more and more current, and he couldn't hear anything. Now listen, to the guy that owns this box, you have to make sure that you step on the foot pedal, then you grab the microphone and hit the mic. If you hit the microphone and then step on the pedal, you are going to burn the contacts out in this relay, this $100+ relay. So at this time, I'm saying, because I've seen them way cheaper than this. Once again, let me reiterate, supply chain thing, I could just only find, there was 2 that were for sale and I bought one of them. Foot pedal, then microphone. Then off microphone, off foot pedal. So, foot pedal, then microphone, off microphone, then off foot pedal. If you don't do that sequence of events, you're going to burn the contacts on the relay and you'll be right back where you started. But this thing is working perfectly. It hasn't hung up, hasn't run away, hasn't done any of the stuff that's in the previous segments. So we know that we're good. I feel very confident about this. I can send this out and this guy's never going to contact me again, at least with this issue. But if he does have a problem, I expect him to reach out. Okay, gentlemen, my name is BBI. And without a shadow of a doubt, I am the biggest mud duck out here in Idaho. What that actually counts for, don't know, don't really care. It's just something I say. Got a problem, got a question, give me a call. You want to help support what I'm doing up here, come join the Patreon channel, please. Help support, show a little bit of love. And big thanks to my Patreon supporters. They're the ones that basically drive this whole ship over here. Because they're the ones that go pay for all the cool stuff, like the spoken word stuff, all the interviews, that kind of thing. The camera equipment, all that stuff, the audio equipment. That's them. I say thank you to those guys. Shout out to my buddies at MechMan. Shout out to my buddies at Siglet. Big shout out to my homeboys at Excess Power. Believe me when I tell you, there's more and more on the Excess Power batteries coming. And thank you, gentlemen, and the 1.01% women folk out there that tune in. I appreciate every single one of you guys, and I swear to God, I think that's just some dude logged in underneath his old lady's account and he doesn't know it. I swear. Probably logged into her tablet or something watching YouTube. Listen, thank you. All right. I'm off to go do more cool shit. Gentlemen, I'll see you. Click.